Or okay. All right. I'm recording.
The tendency to attribute order and perception to the order in anatomy, right?
Uh, yeah.
That's that's anatomism. Anatomism.
Mm-hmm.
So that's like where we're trying to answer, you know, back into the source of order, right?
Right. Give it. You know, we have these different networks of anatomical components.
The source of order, the environment is ruled out already because of dualism. So the source of order is we don't know. Let's look at the brain.
Yeah.
We know we have this order. Like they can't deny this, right? Their whole argument rests on we agree on this. There is this order, an organization in behavior and
Yeah.
perception, right?
Yeah.
And they'll try and make you stay on that point, right? But we agree on that point, right? The whole point is whether the basis of it, the source of it is impoverished,
Mm-hmm.
what the source of it is.
Yeah. So.
And then,
Like.
like you'll see theists, they'll say this all the time. Like all the physical or whatever material sources, right, that you can talk about are impoverished. They can't entail it. You know,
Yeah. Like how could a tree grow without God?
right? Or just like because it's the mechanical worldview, right? It's all these structureless mass points that cannot order themselves, that are incapable of ordering themselves. The world is incapable of ordering itself on the mechanical worldview. The
Mm-hmm.
order comes from outside. It's unentailed.
Right. Yeah. We can't see the
From outside the
Richmond.
universe.
Yeah. Well, yeah. I mean, right. Yeah. It has to. Yeah. Okay. So he talks about a clock machine, a clock, and
Does he? I forget what he defines atomism is. There's anatomism and atomism,
yeah.
or is atomism defined later?
Uh.
It might be defined later.
Yeah. Yeah. I don't. Should be here.
Anatomism is the natural extension of the doctrine of specific nerve energies. Uh, what was his name? Mueller's doctrine.
Yeah. He doesn't talk about it here yet. So this clock machine is an example of anatomism. You have the escape wheels, the hands, the pendulum. They all you can disassemble it and assemble it, and it will always work. You can study each part individually. Um, but the machine is not more than its part, the sum of its parts.
Right.
So it says,
The source of order of the whole, the source of all the properties and behaviors of the whole is its parts. They're uh what's the word? Supervened or something onto its parts. Right? So is this is
superposition,
reduction. Yeah.
principle of superposition.
Superposed onto its parts. It's
Yeah.
it's it's I Rosen says it with a different term that I'm trying to remember. No, 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 no. I can pull it up in 2 seconds.
See, this doesn't make sense. I mean, this seems ridiculous to me because
Its properties and behaviors are context free. Yeah, only simpler systems can be invoked. No, the lower when you are trying to understand its properties and behaviors, right? You can't refer to the larger context, right, to inform you about its properties and behaviors, right? You can only refer to smaller parts. No, you can't refer to the larger system. This is, impredicativity versus predicativity.
Right, right. But like, so
Devolving, yeah, that's right. Devolving the properties and behaviors of the whole onto the properties and behaviors of the parts.
right, right. So like this clock, the 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 ability to keep time. I mean, the machine. We agree that the clock doesn't keep time, right? It requires a person to keep time. You know, the calculator
Right.
doesn't calculate. Um, so this
Yeah, yeah. The machine. Remember, a machine is not a system, really.
machine is
Right?
not a right. Okay.
Because
Yeah.
remember, the system, there has to be a closed loop of entailment, right? There can't be any
Right.
unentailed terms. And, you know, everything, pretty much everything is unentailed when
Right.
you're looking at the machine,
Yeah.
right?
You need
Because
a
it's yeah, yeah. Rosen talks about this, right? The final causation or whatever. It's outside, right? It still needs final causation, but it's completely unentailed, and it's like it's the order, right? The order and organization lies with an external agent, right?
okay
That's
external.
what all the semantics is,
Yeah, yeah.
right? All the semantics is now with the external agent.
So does an external agent obviously doesn't mean a man, right? It can be whatever.
God.
Well, well. What do you
I mean,
mean
that's
by
like the whole mechanical worldview. I mean,
right? Right. The whole mechanical worldview is there's a prime clock, the guy that set the clock in motion, right?
yeah, you'll hear Newton and Boyle and all these people say it that
Yeah.
the fucking mechanical world, right? The universe argues for a god.
Right. But I guess okay. Let's take this clock for example, right? The clock can only tell time when a human, a man, is looking at it that actually knows what time is, right? Like you put up
Right,
you
right, right. They have access to the actual source, right?
right,
They
but
like remember when we were talking about signs before, right? Where we were talking about Berkeley's, theory, right?
right.
Uh, there is this quote about signs. Was it in
Yeah,
lecture 7?
yeah, yeah. The one signs. Oh gosh,
Here, I'll find it.
is it symbols or signs? Arbitrariness of signs. Yeah,
Yeah, yeah. The
yeah.
arbitrariness of symbols, right? This is like also Rosen really talks about this. Like the formal object syntax, right, is stripping away all external reference.
And like you said, like a symbol cannot contain its uh like you used the example of spaghetti, right? And you had like the apple means spaghetti. Does the apple tell you anything, right? The apple is a symbol for spaghetti. Does an apple actually tell you anything about
I mean,
spaghetti?
no amount of fucking, investigating the apple and scrutinizing its properties and behaviors is gonna like uh get you to spaghetti, you
Right,
know?
right, that you're right. So
Right. So the quote I'm looking for is the quote by William James on page 128 of the PDF
okay,
page,
128.
page 128.
Ah, shit, I typed it. This
Right.
one right.
And we were talking about this with the paradox of mechanical reason too. It's like if we were to attend to, symbol meaning, right? It needs more. We need to attend to more than just the symbol, right?
Mm-hmm. If a sign is to
If
lead
a
to the thing, it means we must have some other sources of knowledge of that thing. Yeah. Okay.
Right. So basically, the whole all the entailment in a machine, right,
Right.
is in a machine, a formalization, whatever. Say the same thing. It's it's all basically deduction from independent knowledge, and a knowledge that's independent of the deduction, independent of the symbol, right?
So my only brain problem here is you mentioned an external
It's it's
actor.
it's it's a linear chain. It's one way, like a linear chain. Uh, that like where the whole source of the order of this chain is fucking unentailed, right? The order is something else is ordering it.
So
You know,
let me go down a chain. Okay. We have this clock, right? And the clock's in a room with a man, and the man can tell time. So you have this clock man relationship, right? You're
just
that's
to make what I said just more clear, like I talk about this in my notes to compare, right? Like the entailment in a formalization versus in the real world with causality and all that, right? We like it's the closed loop of entailment, right?
yeah.
X entails Y entails X. That's causality. I mean,
But
that's like the real world,
I
right?
uh-huh.
But like the uh the formal entailment, syntactic entailment, right, is deduction from independent knowledge. It's literally uh it's only X entails Y, and never Y entails X, right? So then
Right.
X entails Y, Y entails Z, right?
Yeah,
And
yeah.
then it's an infinite regress, right?
My,
But there's no closure is what I mean. There's no closure of
yeah.
entailment,
My only
right?
problem is you use the word external agent, and I don't really get that. Like, what can't doesn't the clock have a closed entailment without a external agent? Like for
No.
example, well, what do you mean by agent? Like, would gravity be an agent?
Like if we're to understand the system,
Right.
right? The system, like if we're gonna say the machine is a part of a system because it's not a system itself,
Right.
right?
Right.
We would have to include, you know, the agent, right? The agent
Right.
who created it, and the agent who's using it,
Well, that seems
because they have to. That's where we get the independent knowledge from of how to use it, how to interpret it, what to use it for. You know, what
okay.
it's for, to construct it. To take it apart, put it back together. Put it in this context, in that context, and all these other contexts. Because it's context independent. It's structure, right? Its structure is independent of its operation, right? Its structure is fixed in advance,
Right. But
right?
but
So it's arbitrary. That's what it means, right? It's fixed in advance of context, right? So it's arbitrary with respect to context. You can have it in any context whatsoever, and it's still just the structure, the operation, right, of the mechanism. It follows from the structure that's fixed in advance and is fully determined by the structure.
okay. So it requires a thinking man a to for it to work.
Well, I mean, machines, they require energy, right? They can't get this energy themselves, right? Because their structure
Right.
is not dependent on the flow of energy through them, right? Their structure is independent of the flow of energy
Right.
through
They're
them.
not living
Yeah.
things.
Right, exactly. So we need to plug our computers into,
Yeah.
electricity and stuff.
Or lift the pendulum weight on a clock so it can
Right,
work.
right.
Okay. I was thinking more like, if an animal looks at a clock, right? The animal can't keep time of the clock. It doesn't know
Yeah,
what
that's the
time is.
same. That's the same point behind like you need uh in order to attribute to the sign, right? Some symbolization, like it's symbolizing something. What you're doing is just you already have access to the thing it's symbolizing, and you're just tracing it. Like you're just making it refer to that thing that you're already able to refer to by some other means. Just like you're and you just refer to it by that means that you're able to, right? Not the symbol itself. The symbol is just like a placeholder, you know.
Right,
you're
right.
still you're still having to refer to it by the same means you've always been able to refer to it.
Okay, okay.
I mean, the symbol is literally just it's something that's uh cheap to replicate, right? And even cheaper to ignore, you know. So it's like it, and the key function of it is its arbitrariness, right? That you can just have it refer to anything whatsoever, right? And once you attend to it, right, it's like it. If you attend to it, you're ignoring all dynamics, right? Because you're just attending to the symbol, and like, but then you could ignore everything else that's not like relevant. You know what I mean?
Yeah, like
Everything that's that you did that like all the dynamics that constructed the symbol, that maintained the symbol. You know,
yeah, like reducing
you don't need.
reducing
Yeah,
DNA down to 3 letters or whatever. You know, ACT, GCT, TCA. That makes a
like
heart.
you can talk about the machine in purely syntactic, purely formal terms, right? And that's what's required for computation. Really, you need a formal description in order to do computation that's purely like independent of any physical description.
Okay, okay, okay.
Now, I've talked about this in the chat before. I don't like. I hope I'm answering you.
No, I mean, everything you're saying is getting me further along. It's good. Um,
But yeah, basically, I mean, Rosen also talks about this in the machine in the world of formalization. Uh, Analysis and synthesis are equivalent. Semantics and syntax are equivalent. Is basically what that means,
hmm.
right? You can take it apart and uh, like put it back together, like and you don't lose any information, right, in that process.
Okay, okay.
But like that's just like something you'll see in Rosen.
Yeah.
He gives the whole explanation in those terms.
So here's this is Descartes saying that he thinks.
Oh, we're also talking about impredicativity here, right?
Right,
Yeah.
right.
There is no impredicativity, right? Remember, it's devolved completely onto the parts, right? But then, those parts themselves have parts, right? So like if we're gonna apply that, like if we're gonna extrapolate that to like a natural law, right? Like reductionism,
Yeah.
uh, the the basis of causality is in parts. Is that what how I defined it before?
Yeah, like
Something
how
like.
yeah, like eventually you'd have to say the clock is made out of atoms, right? That's the parts. And then no, the clock is made out of quarks. Those are the parts that make it up.
Yeah, it's an infinite regress. I mean, it's but the premise is the premise is stated very simply. Yeah, that's how I define reductionism. It's the position that parts have causal primacy,
Parts have
not the whole,
primal causacy.
like that they have
Yeah.
causal primacy, right? When
Yeah.
we're talking about an action, right? It's not the entity acting that has causal primacy, it's the parts, right? So,
Right,
and then
right. And then
where is the entailment, right? Like the parts entail the function of the whole, right? So where do the parts get that function from?
well, they get it from the
Wh- wh-
previous parts, obviously.
right, exactly. Right. but the impredicative view is that the function is from the whole, right? And the parts are differentiated, right, and organized and all that with respect to that function, to
Okay.
their mutual realization of it.
Okay. Okay. So Descartes, obviously, he thought humans were analogous to machines, and that led him down, his path.
He thought the world was a machine.
Yeah, right. Yeah, I guess so, right? Yeah, he thought the world was a machine.
I mean, that's like the first sentence in that section.
Yeah,
Descartes presented us with the thesis that the world is a machine.
yeah,
He argued that the physical world and everything in it must be explained in the way that we explain machines, to the
yeah,
sizes, shapes, and motions of their independent parts.
yeah.
Right? They're totally like they're totally not like dynamically connected. There's no dynamic interdependence of parts. Right? They're all basically, it's like the assumption of like in a lecture. Turvey describes it like this, right? It's the assumption of like a priori components fixed in advance, right? Like just like the structureless mass points. You know what I mean? It's
Mm-hmm.
it's platonic forms, right, that are assumed as like the building blocks, right? The structureless uh points, right? The structureless atoms or whatever, molecules, right? Structureless particles. Sorry. Structureless particles.
Like the billiard balls, right?
Right. I mean, Rosen talks all about this. How do we get syntactic objects? How do we get formal objects? What we do is uh we totally disconnect it from the original dynamics, right? And all these like little syntactic objects are not dynamically related at all, right? So we can formally relate them arbitrarily, syntactically, since they don't change each other, in physical ways and stuff like that.
Right, right. Yeah, we've got these little particles that have their own properties, and they.
Right, and the way we do this, right, is, I mean, this is how computational engineering works, right? We dig like a potential well. This is what a transistor is, a logic gate is, a discrete switch,
Okay.
right? Completely Boolean measure. We dig a potential well, right, that's deep enough to trap any sort of substructure, right? There's like this dynamics going on. There's energy flowing or whatever. It's
Right, right.
the electricity, right? You know and we just take some substructure out of that, right? And we're able to trap it in like it's a potential well. This the term for it, right? It such that it under ordinary fluctuations, right? Its own activity, right? It's not able to escape that well, right? Because the barrier is energy, right? It can't uh
Right, right.
escape it. It doesn't have enough.
Yeah, we
You
need
know
to
what I
give
mean?
it more. We give it more energy, and that lets it create
Exactly.
escape. Okay.
Right. So what we can do then is just ignore it. Ignore its material properties. Ignore the dynamics. Ignore the fluctuations. Right, and just treat it as a purely syntactic object. Right, with a Boolean measure. Either it's in the whole or not. You know what I mean? It's one or zero.
Yeah.
And you obviously you can't get the electricity back from this substructure. Like you can't or recover the original dynamics, right? That information is lost irreversibly. It's irretrievable. You know what I mean? And that's the whole
No.
point. It's supposed to be. You're not supposed to be able to, by any internal means, right, in the formalization, by any internal syntactic means, you can't uh escape the formalized world, right? You can't get back to semantics by any internal syntactic means.
I don't. quite understand. Like in the case of the transistor well, what do you mean it can't be like I
By
don't
any internal means,
by
right?
any
It can't get out of the fucking get out of the well by its
the
own.
water okay,
Right.
right, okay, right. The water can't get out of the well by itself, no matter what. Right.
Yeah.
Makes sense.
Uh,
Yeah.
but the whole point is that it's not it's no longer connected in the way it was before, right? To the original dynamics, right? That is all the dynamics that is literally, uh like making it so that we can treat it as something that's inert, something that's non-dynamical, right? That like it's like all these there's all these dynamics that it's like tracing a irreversible ring around it so we can treat it as reversible. We're exporting all the irreversibility out of the inside of this ring. You know what I mean? We're exporting all the dynamics out of it.
Okay. I think I see what you're saying.
And Howard Patty is the one who really talks a lot about that. Like you can
Okay.
search in the chat and stuff. Like I've linked to him about that. But it's also all this stuff is in my notes too. I have all
Mhm.
explanations of all this in my notes. You can find.
Mhm.
But
Okay.
yeah, like that's how we actually like a secure, a formal description, right? For computation, it's necessary for computation. You see what I mean?
Yeah, yeah, yeah. Yeah, I think
Like that's what computational engineering is all about.
okay. I'm trying to think about what else is in this chapter.
Sorry, I keep rambling on, where you gotta stop me. You
No,
know,
no, again, I mean, it's just me and you, and we's just chilling. Like, this is,
look at this. He says, I do not recognize any difference between artifacts and natural bodies, right?
yeah, where's that?
And you'll see I make that distinction, like a natural object and an artificial object, right? That's the distinction here. The syntactic object and a natural object, the object that's, like the dynamics are suppressed so we can treat it as a syntactic object, right?
Mm-hmm.
It's a artificial, like, you know, I'm trying to remember. I explain it all in my notes. I just want you to, like, I'm trying to tell you what terms you can search for in my notes.
Yeah, yeah.
Like artificial and natural or whatever, like in like those are in other specific notes where I'm like where I had a lot to say on, like I'm saving it for later, right? A specific point, right?
Mm-hmm.
And I have a lot of stuff in there from Rose, and like the notes are like titled like entailment, or like the one is titled something computation, uh and the other one is like entailments is something, right? That you'll find it in there. There's a lot of like cool stuff to talk about there, like the distinction between artificial and natural objects, right? And like the whole, like that's my whole discussion about like entailment, right? Like I'm trying to distinguish, right? Like how Rosen talks about it, right? There's inferential entailment, right? And then there's causal entailment. And the inferential entailment, right? It's just really is deduction from independent knowledge, right? It's the one way. I mean, it's the linear chain, right? The infinite regress. It's always an infinite regress. And then the other side is, right, the impredicative loops, right? Closed loops of entailment. So I make all those distinctions like very clear in my notes,
Yeah.
because I mean it's important to know how artifacts are derived, like the natural objects are primary, right? It's what you're doing is you're destroying the natural object in order to get the artifact, right? You're destroying. It's like that's what we were talking about at the very beginning, right? We're not in this lecture, in lectures, like all the lectures, right? We were talking about how living things are a natural classroom for studying things without like destroying what you're trying to study, right? Without taking it apart, right? And just isolating parts, right?
Right, right.
Because then what you're doing is you're just destroying everything that depends on, the integration in the whole, the the impredicative loops, right?
Yeah, absolutely.
If you try to fractionate x or y from the imperative entailment of x and y, right, then you lose everything about x and y that depends on that
Yeah.
relationship.
Right, right. Okay.
And that's like I mean, that's not inherently a good or bad thing. That's just uh that's how you get to the world form of formalization and all that stuff, right? How you get to you secure a formal description and you have these syntactic objects that you can uh put in one dimensional sequences, and you can uh like have like put make rules out of them to order other syntactic objects,
Mhm. Mhm.
like all that stuff. I mean, it has its place for sure, right? It definitely has its place, right? Fucking computers and stuff. But it's very it's it, it's a mistake to extrapolate from that. Fucking like that's what the universe is like, you know?
Oh my god. This fucker is accusing me of editing the footage. Sorry,
Who,
G.
Casimir?
Yeah, Casimir. Yeah. I gotta stop looking at his shit. He's pissing me off now. Um.
Yeah, he DM'd me. He said, I figured out how to revoke the ban and it was just revoked. I asked
Okay.
Zulu to send you a server invite when he wakes up.
Yeah. He's accusing me of that. There's that like 30 minutes where you left and I left, or however long it was, and yeah, I stopped recording. Like I wasn't there. So I guess
Okay.
he thinks that I gave you the full copy of the recording and I'm just hiding the
I didn't even
rest.
watch it. I
Yeah.
didn't even watch it.
Yeah.
Okay, let's continue. Let's
Yeah, yeah,
continue.
yeah. Let's get it. Okay.
Okay. Yeah.
Uh,
Machine metaphor, right? You see what he says?
yeah.
Each unit is absolute in the various senses of stands alone, not dependent on anything else, and self sufficient. I wouldn't say, I don't know. Self sufficient is not really, that's more like a philosophical term. Uh, like the way he's using it. But the existence of a mechanical unit is independent of whether the machine is operative, right? Like I said.
Mhm.
And there's this other paper by Turvey where he talks about Rosen's view here, where he tried, like, the impredicativity paper by Turvey. Here. Have you read this paper?
I don't believe so.
Here, hold up. I'll link it. This is an important paper. But you also see this in Rosen's. Like, this is the same thing I was talking about, the artificial natural objects distinction, right? The mechanical units versus functional units, right? Or mechanical components versus functional components. And the entailment, right? The like function is entailed by the parts, right? In the
Right.
mechanical view, right? And then, but in the other view, in the view, a functional component, right, is its function is entailed by the larger system. like those two directions of entailment. And I think that's like a good way to understand these things. Here in VC text.
Okay, VC text. Um, yeah, I have not read this.
Or the introduction there is like just like the introduction of the book, but the first chapter is the paper. You can search like
Oh,
mechanical. Yeah.
okay, okay. I see. It's not a whole book. It's just the first chapter. Or it's,
Yeah. This it was essays, you know. So
yeah, yeah,
if you search mechanical components, you see following rows, and we can say that anatomical components, in common with mechanical components, are characterized by the direction of entailment. Function F is entailed by its component C.
yeah.
In the natural world, entailment is causality. In the formal world, it is strict implication, or deduction from independent knowledge.
Right, right. Okay, yeah,
So you'll see he'll say this same like spiel, right, about like the direction of entailment for function, right, in various papers, right, and this comes directly from Rosen. Rosen has like whole fucking chapters on it about mechanical components and functional components, and you know the uh importance of those concepts.
okay,
You there?
okay. Yeah, 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 yeah. I'm reading. Yeah, C imply C to F, and yeah. Okay, okay.
And and that's also connected with the autocatakinetics stuff, obviously.
Yeah,
But
I
you'll
the
see like here I'll link Turvey's other paper uh in 2013. That one's in like 2017. Turvey 2013. Man, I can't ever find it in my files. I always have to go to Google Drive to search for it. Like I search for it in my files and then I can't find it. I gotta search in Google Drive and then I find it. Here. He says the same thing here, but he also talks about incommensurability, and like autocatakinetics in this paper. But he says the same thing about the directions of entailment, like F, B, F, or
yeah.
yeah. But just like more, like context on what he's talking about here. Yeah. This is all really important stuff. I mean, I think it's really important.
Yeah,
Like I have a lot of notes on it. So obviously.
yeah. It's just a lot.
Yeah, that's why I try to like that's what I'm doing with my notes to try and, generalize it. You know
Yeah.
what I mean?
Yeah,
To make it
I
easier to grasp and then apply like to all these uh all the cases, right, that it applies.
yeah.
Just like to get a method of, just like identifying these things and like using these arguments, right? The arguments that are implied,
Yeah.
right?
Yeah, and
And
I think
this is
okay.
basically what I do in my notes. So you can
Yeah.
find it in my notes to help you with that.
Yeah. It would just be nice if it was less like this lectures on perception. It's just been a lot of, examining the problems that led people, and so hopefully part 3 is going to be, here's some cool stuff.
Yeah.
Like, I mean, I think, don't get me wrong, the history is important, but it's 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 a lot. Like, even, chapter 14. I think we're. I don't know if you have anything else to say on 13. Um,
I mean, you have the reins, bro. You
yeah,
don't
yeah.
worry. say anything. There's a lot of stuff in chapter 13 that's important, bro. I mean, chapter 14 is the one that's not that important.
Yeah,
Chapter 13, chapter 13 is really important.
I pretty much skipped for. I mean, I read 14. Um, I think this like morphological reductionism is important, but uh, just learning about like the whole fields and stuff. It's just like what.
Yeah, I mean that stuff's not important.
Yeah, yeah,
But basically here to end 13.2, right? It's Rose. This is another point from Rosen, right? Abiding by the machine metaphor, right? As like you know, okay, yeah, the machine metaphor and the central notion of mechanical unit constitute the cornerstone of modern methodological principle of reductionism. Yeah, fractionation of a machine into independent parts into simple machines can be extrapolated to the world at large. For any material system, including the universe, there is always a set of parts into which it can be decomposed without losing information about the system, right? So you can always, recover the original system, right, from its parts. But what that also it's also the view of formalization from Hilbert, right? That you can always formalize it, right? You can always you can reduce semantics to pure syntax without losing any information. That's Hilbert's view, right? But Gödel's theorems prove that wrong, right?
yeah,
You will always lose information in formalization, and you will always be destroying, right, what you're formalizing.
right, right.
And that's a really important point from Rosen, that they're saying that you don't lose any information,
Yeah,
right? Like from you can translate semantics to syntax, and you don't lose any information in the process, and then you can just bring it right back to semantics. You can just deduce from the syntax, right? That's fixed in advance. You can deduce all the semantics from it,
yeah, including the universe.
right? And there's a very important connection to the second law, right? That I mean, irreversibility, right? It means you will always lose information in such a process.
Right.
And Howard Patty, he talks about that a lot, connecting that like loss of information and the second law. Billiard balls and being particulate.
Yeah, yeah. I mean, we kind of touched on that. The billiard bars are perfect because they have all these different properties that can't be sensibly added to the others, or so on and so forth. And
Right, but remember these are not. It, remember, it seems super objective, right? To define the world in abstract properties that are independent of context, of the observer, of anything, right?
hmm
Anything else sounds super objective, right? But it's actually an extremely subjective view, right? Because it's all made up, right? It's the
yeah,
world of the platonic forms. You know what I mean?
right, right. Okay. Um,
These abstract Euclidean and Newtonian property. We talked about that.
yeah,
We
why?
talked about all that.
Yeah, a while ago. Yeah, yeah. Machine has a simulacrum. Uh,
Oh yeah, this is a very important one.
yeah, like everything should be reduced to a mechanical model.
Let's see if you could like see the point here, like the real like important point here.
Uh, well, I guess to me, what I thought was,
It's the last. It's really the last paragraph. I mean, he
yeah,
says it at the end. He's like, "What makes this important?" Right? Like these last
yeah,
paragraphs here. Well, these like the paragraph
yeah,
before that.
yeah.
The paragraph before that too.
The Turing machine one.
Yeah, this is all from Rosen as well. Well, yeah, okay. What is a machine, right? You should start there. What is a machine?
Okay. Hint at the machine simulacrum. Such an answer is not forthcoming. It does not follow the explication of mechanical units. For example, those that compose a clock and the principle of superposition. A machine is a simulacrum. System that's thinking consists of symbolic operations on special brain tokens. Jesus Christ. That guy's fucking stupid. The other is a dual.
Psychological atoms, you know,
Yeah.
sensory atoms, sense data. It's all the
Yeah.
same, it's all the same view. It's
It's
all the
all the
same
same.
idea.
It's all the same. Yeah. Okay. The other is the dualism of system environment, states and dynamical laws. Uh, the Turing machine, blah blah blah. Mathematical Hobbesian machine, where the parts come in different size, shapes, different motions. Get out of here, cat. In a Turing machine, meaningless symbols are analogous to particles. Further fixed rule. At root, the mathematical machine and the Newtonian formalism for material systems are identical. Recursiveness is the core of both. For both formalisms, conversion of the present to the immediate future exhausts their entailment structure. Right, okay, yeah.
Yeah, so remember, Newtonian physics is not a fucking description of the world or natural objects or motion or anything like that. Right?
Right.
It's a description of this formalized universe, right? Of
Mm-hmm.
structureless mass points, right?
Yeah.
Which are literally just meaningless symbols. They're the same thing as the meaningless symbols in Turing Machine. And Rosen really, really uh goes into great detail to show this in his book Life Itself.
Yeah, I have that book that I need to read. Um
Oh, and yeah, it's really more in Life Itself, but essays on Life Itself is also really important there.
any mathematical system, for example, Euclidean geometry, stripped of its external reference and encoded strictly by syntactic rules is designated formalizable. Okay, sure. Mathematical system that can be formalized is equivalent, therefore, to the strictly syntactical by definition mathematical machine of above. The primary consequence of this equivalence is that a machine can do the mathematical formalism. Simulation is what machines do, and a system is a machine if it simulates or can simulate something else.
Right. Think about launching a rocket to the moon,
Launching a
right?
rocket, right?
Uh it's not it's it's simulating, right? It's all just simulation, right? What the machine is doing, right? The connection to, anything physical, right, is done by the agent,
Right,
right?
right. So Newtonian mechanics that lands a rocket on the moon is just a simulation. It's just a machine.
Yeah, it's just pure mathematics,
Yeah,
pure
yeah.
Euclidean uh geometry,
The equation of
like
machine.
calculus. Yeah.
Yeah. Equation of machine simulate da 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 da.
Like it's like this is what I mean, right? The rocket
Right.
flying through space,
Right.
and the calculations going on, they're not the same thing. You know what I mean?
Right. 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 Rosen has stated this possible interpretation more formally. Purely syntactic models of material nature are too impoverished in entailment to mirror the causal sequences which can occur in nature. Yeah. I mean,
And this is
all.
very important. What a machine, like the machine taken as an explanation of something, right? The computer taken as an explanation of something. The neural networks, right? That's why we
Yeah.
started the lecture with the neuron doctrine, right?
Right. Oh, okay. Right.
Now you see, right? That's
Yeah.
why we
Yeah.
started the lecture with the neuron doctrine, right?
Yeah.
What is this actually? What can this explain, right?
Yeah. Nothing.
It can't explain anything in the world.
Yeah.
That's for sure.
Yeah. Okay.
It's just simulating whatever you already what's fixed in advance. You know what I mean?
Right.
And Rosen has a whole fucking chapter on simulation and like what that means.
Okay. 13.5. Helmholtz influential
Simulation
mechanical.
is what machines do.
Yeah.
That's a very important concept. I mean, in light of Rosen.
Right.
It's like it's basically saying any arguments like anything we say about formalization, we're also saying about machines, right? Or formalisms, right? Formalisms and machines are equivalent.
Right. Okay. So then we get Helmholtz's view with attraction and repulsion, and yeah, they talked about the caloric theory of heat.
Oh yeah. This is important. Zulu just invited me back though.
Yeah, you're good. You take your time.
I gotta ask him to get my roll back.
Yeah, the paper boy or paper man.
Uh, all right, I'm back in the server now.
Oh boy, yay.
I have my role again. I'm the paper man still.
Good. Nobody else can fill your shoes.
Okay,
Big
good.
shoes. Big shoes you got.
Let's see. Where are we?
13.5 with Helmholtz influential
Yes.
mechanical view.
Oh yeah. Basically, I mean, you'll literally hear the fucking Schopenhauerian dude. What's his name? Boots, right? You'll literally hear him talk about like, hey, it's all just attraction and repulsion, right? He's a fucking Kantian. Uh, and like, well, Schopenhauer's getting this from Helmholtz, who's also a Kantian.
Mm-hmm.
Yeah. uh, basically, I brought this up to Boots before. No, no, no. Yeah, the lesson here. Like the fucking the Einstein and Infield summarize the state of affairs. Maybe I need to go up a little bit. Uh,
Yeah. Einstein.
Belaboring these examples of the mechanical analysis. Yeah, all right. The mechanical analysis. Remember, now we see the context, right? I feel like we've established the context pretty well to understand all this, right? Of the
Okay.
lecture,
Right.
right?
Yeah.
The examples of mechanical analysis of material phenomena, and we've already seen the limits of that, right?
Right.
We've glimpsed at the limits of that, right?
Yeah.
So we know that we can't get closed loops of entailment, right? So we're gonna have all these unentailed terms,
Mm-hmm.
Right. Just like we've been talking about this whole time from the first lecture, right?
Right, right, right. I'm
Right.
with you. I'm with you.
It allows us to appreciate that the mechanical view could be consistently carried out, but only by inventing novel massless substances, new kinds of material agents with their own special material properties. Einstein and Infield summarized this state of affairs thusly. In the attempt to understand the phenomena of nature from the mechanical point of view, throughout the whole development of science up to the 20th century, it was necessary to introduce artificial substances like electric and magnetic fluids, light corpuscles, or ether.
Right. Okay. Okay. Okay.
Right, and we were talking about
Yeah.
this. Yeah.
Yeah. I mean, I've watched a lot of Inductica's videos, so I I know about the whole ether theory stuff.
It's the mechanical view. I mean, literally, he's talking about the mechanical view. Like, he's like,
Yeah.
What is the white light waving, right, or
Yeah.
whatever, right?
Yeah.
That's he's talking about the mechanical like waves, like where's the
Yeah.
mechanical waves?
Yeah. For something to wave, it needs a substrate to wave in, so there must be an ether.
Yeah, he's just like conflating, the formalization, right, with what's going on in like the real world, you know,
Mm-hmm.
like wavelengths and stuff like that. That's like it's like these are symbolic results, right, of an extrinsic measurement. Like it's fixed in advance. What you're measuring is not the thing. You're measuring uh the symbols that you've replaced the thing with. You know what I mean? The Boolean measure, right?
Right.
Like the potential well, you know? You're in a purely formal description as soon as you use that extrinsic those extrinsic metrics which are fixed in advance. Right. When you're measuring the wavelength of light at a quantum scale, right?
Mm-hmm.
Like is it a photo multiplier
Sure. Yeah.
or
Sounds.
like a that's maybe, or it's a photo multiplier, or like a radio transmission thing,
Yeah.
radio antenna kind of thing.
Yeah. You're
You're
seeing
not going to
the.
be able to recover light from this, formal description, right? Is the point.
Right. Right. Right.
Without independent
Well,
access to that knowledge, right? You're looking at the wavelength, the fucking like the drawn on paper, right?
I
You're
mean,
not gonna
yeah.
be able to like it's like the spaghetti and the apple. You know what I
Yeah.
mean?
Yeah. And you're at a completely different scale from where the light should be looked at.
Right, I mean, it's just light is energy, right? It's scale invariant, but it has scale specific, consequences, scale specific like morphologies and forms
Right.
and like
Right. So,
and geometry,
okay.
you know?
Okay. Right. 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 Scale invariant, but scale specific
Yeah,
morphology.
yeah. This is what Penrose actually talks about, right? In his theory of like what light is, right? It's like he just takes, well, he doesn't he doesn't bring in the scales. Like he doesn't bring in specific scale. He doesn't go into scale specificity
Yeah.
at other scales, right? But he goes into he talks about it in terms like it's conformally invariant, right? So we just have to understand it as like literally the geometry between things, right? It's not like light is being transmitted from one thing to another. It's that it's literally connected. Like there's like if you draw a line from the edge of this thing to the edge of that thing, like light cones. You know what I mean?
Yeah, yeah, yeah.
You know what I mean? And that's the light right there. That geometry, that like, and that's like the relations between the thing. You know what I mean?
Yeah. No, I
And
I
that's
like
just like how it is at every scale. It's conformally invariant, like, and it conforms to the objects at every scale, right? Obviously, you know what I mean? At every scale, it's specific
Oh,
to the
it
objects.
conforms. Okay, okay. That's
You get what I'm saying?
yeah, yeah. I think I do, right? Yeah,
And this is like part of contemporary physics, bro. Like Penrose's understanding here, with like conformal invariance, like talking about light, right?
yeah.
Because he's trying to talk about light not at any like specific scale
Right, right.
in conformally invariant like terms. That's this whole thing. But it really gives credence to the ecological optics, right?
Yeah. You have, but and you have to be at the right scale when you're talking about, you know.
Right. So it's saying light is not restricted to, this micro scale with micro phenomena, right? It has scale specific structure at all these other scales,
Wait a minute.
right?
Okay. What is there something special like light is scale invariant
The
and
structure of light, right?
the
We're talking about the structure.
structure.
That's the second law, not the first law,
Wait, the
right? The
stru
structure is the geometry, right? The distribution of energy, or the distribution of potentials, right? The distribution of the conservation, right? It's a non-equilibrium distribution. It's not homogeneous,
Wait,
right?
you
It,
this
it
but this the structure of
it's
light
a,
is different at different scales, right?
right,
Okay, so
but
this
it's energy still. Energy is
right,
always conserved, right? I mean,
right, right,
as far as the first law is concerned, energy is just like there's no processual or like structure terms with respect to the first law, right? It's just invariance. It's a symmetry, right? And then asymmetry is with the second law.
right.
So you have light, right? It's scale invariant, right? It's
Scale
just
invariant.
uh, right,
Right, right. I'm with
but
you.
you can have the same, light, right? It's like this light right here, right? I can when I go to the scale of like quantum phenomena, it's gonna have a structure specific to that scale, but at this scale, it has a structure specific to this scale.
Right.
Right. You get what I'm saying?
Um, I do. This is to me this is a very important topic. This is like what I this whole scale thing is really what I want to get deep into. But because like I'm thinking back to what you said a couple lectures ago when we were talking about how you mentioned like by examining the scales, you sort of like can loop back to a different scale. And I feel like I almost like figured out what you were saying, but I haven't grasped it yet.
It's
So
it's it's all about impredicativities, bro. Right? Because it's all about the loopiness of impredicativities, right? Because uh, think about it like this, right?
uh,
What an impredicativity is, right? Is you know x you can only understand x in terms of y, and y in terms of x,
right,
right? But they're not the same. The
right,
only reason for this is because they're not the same. They have distinct independent like identity that you know that's described in reference to the other thing. You know what I mean?
right, right,
And it's only because of that, right, that they're able to, be defined in terms of one another, right? But you can only define X in terms of Y and Y in terms of X, right? That's really what an predicativity is, right? We're talking about the organism in terms of the environment in terms of the organism, right? Perception in terms of action, action in terms of perception, right? It's the same thing. every time.
Yeah. Okay.
Energy in terms of entropy, or really like the because we're the way we define the first law, right? It's you know, e- energy is not created or destroyed; it only changes forms, right? Changing forms. That's the second law. That's what the second law has to do with, you know.
Right. Okay.
But there's a lot of ways I can explain the mutual entailment, right? The first and second laws.
Mhm. Okay. Okay.
Hey,
Am
G.
I on track here? Like I kind of like don't remember your question. It's like your question was about like light and like invariance laws, something
Yeah.
like that.
I was just making sure you know we both agreed like yes, light is scale invariant, and then you said the structure of light is scale invariant. So I didn't know what you meant by
No, no,
that.
no, not the structure of light, right? Just
Right.
how it's structured.
Yeah. Is
You know what I
scale
mean?
dependent, right? Like the way it.
Like how it's structured, right? The same. It's structured uh invariantly, right? Like what I mean is like the way it's structured at each scale, like it's structured like as the relations between things, like the very relations between things. You know what I mean? But at each
Mhm.
scale, it's specific to each scale. You know,
Yeah. Right. Right. I agree with that. That makes a lot of sense to me.
like structure is scale specific.
Right. Right. That's what I was thinking you meant. I just wanted to make sure because I got I wasn't sure. Okay. I think input error had something to say.
Yeah. Hey, G. What happened last night? Just
I don't know.
were you banned or
Fucking,
something?
I got banned, but I'm back now.
What happened?
Fucking, I was arguing with Casimir. I mean, arguing like, but he was like, you can see the discussion. We kind of had a discussion about it in the chat here. All right, you can see Stratino Greta Garbo. He gave a whole like his whole thoughts on what was going on. Right.
Right. Yeah, I try to like tune into the podcast, but I don't
We
know.
we were talking about it for like an hour before you, like before we started talking about the ecopsych stuff. But right now we're in the middle of like talking about this.
Right.
So I don't know. Uh, I don't really care. It's just like, I mean, Casimir is just being Casimir, right?
Yeah.
It, he's just exposing himself as the way he debates is not really good faith.
Well, he just gets so like psychotic.
Yeah,
I don't know what that's all about.
yeah. I mean, I think it really you. I mean, you kind of get an idea from what. There's a recording, by the way. So
Okay.
oh knows put the recording in the chat, but you can sort of get an idea of what what that's all about because if we kind of got into it. It's really like he has this whole like he just imagines like where he wants to take the discussion like in his head. You know what I mean? He just like has a whole like he literally describes it as like a castle, that he's building. But
Yeah. Yeah.
like a
Brick by
logical
brick.
castle. Yeah, but it's like he's not in the discussion. You know what I mean? He's not following. He ignores everything you're saying so he can just impose his own like whatever the fuck, right? Irrelevant thoughts, right? To make some point way later, right?
Mhm.
But I think that's why, right? He gets like that. He's like always he's just trying to control the like your every move, your the whole discussion. You know what I mean? He's very controlling. You know what I mean?
Yeah.
Yeah,
It's
I
like
can't.
it's just those type of people who get like really frustrated when people don't do exactly as they like people aren't acting exactly as like they planned, you know?
Yeah. Well, it's a good thing he's an authority figure, you know. That's always.
Yeah.
Yeah, I mean, I try to tune into the podcast, but I don't know. They
Yeah.
seem like just the same things being said over and over again.
Right, and then when I came in, I was like, "Bro, you guys are fucking wrong." Like they got all fucking mad, bro, because I came in. I'm like, "Bro, you like I knew why this is going nowhere, right? Or what they're saying nothing, you know? It's because they're not fucking like like I was trying to bring in like Rothbard, you know, he had this whole like theory of intervention and like analyzing intervention and like all the implications of that and everything, and they don't know shit about it, you know. And
Sometimes,
I
yeah,
that
sometimes I
would
do.
be very important. That would be very important for, I mean, the podcast, The Remnant, right?
Yeah, sometimes I do wonder when it was like when the last time Zulu like read something, like brushed up.
No, I mean he's really like he's a big rationalist on a lot of things.
Yeah. Oh,
I,
I didn't mean to derail your conversation. So
Yeah,
you're good.
we can just continue.
Yeah.
All right. I
yeah,
need to drink water though. I'm fucking
Okay.
thirsty. Let me get some water. Shit. Yeah, talk the lesson, bro. The lesson. What's the lesson? Belabor the lesson.
Belabor the lesson.
What?
To belabor the lesson further, what is brought out by the analysis of light is the sheer multiplicity of substances if light is viewed mechanically in terms of corpuscles, and the sheer complexity of the single substance ether if light is viewed mechanically in terms of waves. In the corpuscular theory, each color behaves as an unchangeable substance. To explain light's properties requires as many substances as color. Okay, that makes sense. You would need a red corpuscular and a pink corpuscular and a blue. If to the contrary light is a wave and colors are the component frequencies of the waves, then light is a transfer of energy, not a transfer of frequencies. However, for this energy to occur, you need the light wave to travel, so you need transparent air like so da 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 da. You need the ether. Waves cannot exist separately from the material media in which they vibrate. How could you have this ubiquitous ether? Uh, the ether's properties seemed extraordinary and contradictory. For example, the ether I mean, yeah, Inductica goes over this, of course. The ether had to be sufficiently rigid to transmit the extremely rapid vibrations. Um, Further, the simpler interpretation of the ether as air-like transmitting da 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 da. Um, I will say, this isn't a very good argument um, against the ether theory. Like,
Yeah, he's not. He's not
yeah,
making the argument.
I know he isn't. I know he isn't. I'm not. I didn't mean to click that.
He's just giving these examples.
Giving these examples, yeah. Um,
Like we're rational. We're in pure like rationalization right now. We're
yeah,
like
yeah, yeah,
we
yeah.
need the
If
ether
yeah,
because we're missing this thing.
and it
We're missing this thing, so we
yeah,
need this thing.
and the ether,
And it has to be this. It has to
yeah,
be these
yeah.
things.
It has to
You
be a
know what I mean?
jello. It has to be homogeneous. It has to be isotropic. Where am I saying
And
this from? Well, it has to be.
how did we get here? How did we
Right.
get here? Well, because we're missing these things in our theory.
Okay. Um, all the issues pertaining to the mechanical perspective articulated by Helmholtz came to a point in the ether. The eventual failure to provide a sensible, mechanically consistent model of the ether and then failure to detect it, were a major consequence. Einstein and Enfield drew the following conclusion. Science did not succeed in carrying out the mechanical program convincingly, and today no physicist believes in the possibility of its fulfillment.
Yeah, they're all fucking skepticists. their
So
whole theory didn't work out, so they're like, they throw up their hands and just like, well, I can't tell you the sun will rise tomorrow.
is it well? And I've had this argument with Eddie. You know, the reason I don't like modern physicists is because of the whole pauperism. You know, the they only believe in things that can be falsified, right?
That's like you don't want to look at Popperianism as the root, right? Because that's just like there's many interpretations of it, and then that's just like totally like downstream, you know? What's
Uh,
really happening here, what's really happening here is like my theory, like at the outset, it has is defining problems as intractable. That I need to invent all these imaginary, like entities, right, to account for something, right? Because it's missing in my theory.
yeah, sounds a lot like Descartes. You know, oh, I know I can doubt myself, right? Like that's the only thing I know is that I can
Yeah.
doubt everything. So therefore, yeah, okay. Like, oh, okay, we know we can prove that something's falsifiable, or we can get to falsifiability, but that we can't prove anything. Yeah. Okay.
Yeah, I mean, falsifiability is a useful heuristic tool.
I
I would say.
I agree, and
You know,
I yeah.
I don't think it has anything. I don't think it's really the source of skepticism in science, in modern science. I think it's a lot of the source of skepticism is literally just like bad epistemology, and like bad, like literally falling right into the mystic's hands. Like the
Oh
mystics
yeah.
want you to be a skeptic. You know what I mean?
Yeah.
Like they accept the same impossible standards as the mystic, that knowledge is impossible because the standard is omniscience. The fucking mystics and the skeptics both hold that same standard. You know?
Yeah, yeah. I mean, that's what you were saying to the Thomas, right? Like your standard is
Right.
omniscience or no knowledge at all, and what's going that's
Right, the mystics, bro. They want you to be a skeptic. They want you to. That's why they want you to be a skeptic, bro.
right, right. Okay. In summary,
But like, I have a bunch of notes on that. Like just like the fucking like the source of like skepticism in like modern science and all that, right? Like what there's like a note like cycle of skepticism, mysticism in my notes. Uh, there's a couple of notes on that.
okay.
Just like I had a bunch of thoughts on that. I just don't want to get into it right
Yeah, yeah, yeah. No, no,
now.
we're fine. Um, 13.6. In summary, the notion that the order in living things and the universe at large is mechanistic is the notion that order arises from material parts that are 1. Independent and unalterable, 2. Specified uniquely by their properties, and 3. Superposable in indefinitely many ways. Said differently, mechanistic order is the sum quantitative changes in a small number of basic entities that themselves never change qualitatively. Said differently,
Right,
mechanistic order.
they're qualityless. I mean, uh, this mechanistic order description not really that good. Uh,
Okay.
it's not really simple enough. I mean, Swenson is where you want to get this from, really.
Okay.
When he talks, he makes it really clear. Like this the mechanistic order or whatever is literally like it's qualityless, structureless particles. They're meaningless, right? They're like he really goes into it.
Yeah, Swenson, he's definitely probably the next guy I'll read. I really want to read Rosen, and I actually think this book that you just linked, The Ecological Brain, that looks interesting, but
It has some good history about like neuroscience,
yeah.
cognitivism and neuroscience. It also talks about how some like the history of like ecocycle a little bit, and it's like it rejects the notion that ecopsych was in reaction to cognitivism, the cognitive revolution and all that. Like,
Yeah.
because they found their origins really around the same time, like in World War II. Both Turing and Gibson were, starting their stuff with that in World War II. Turing with like the, code breaking stuff, and and Gibson was with the pilots, right? Training the pilots.
Yeah.
But basically, they developed side by side through the history, right? Just taking different paths.
But you
They
don't
were
like,
both they were both in reaction to behaviorism, actually.
but you don't agree with the findings in Favela's book, like or his theory.
His theory? No.
Okay, I don't know what it is, but the NEXT, neuro ecological nexus theory.
Yeah, this fucking just the name is obviously so cringe. So like, no, I'm not gonna.
I don't know, man. Acronyms are cool. What is next? NEXT. Yeah, that's a little
It's really cringe.
okay.
But yeah, he's a neuroscientist, so he likes to focus on the brain, and like, he doesn't talk about thermodynamics. So then obviously I'm gonna discount what he says about the brain because he's not talking about thermodynamics.
Okay, okay.
You know what I mean? Like
Not specifically, no, but I mean I know it's
what
important.
I would want to see is him explain it in thermodynamic terms.
Okay.
Right? Otherwise, I'm thinking he's misattributing stuff to the brain and not actually understanding what the brain is doing, and why we have brains, right?
Right, right. Okay.
Like I explained to you before,
Right, right, right. All right, all right, all right.
Yeah, so lecture 13. Final thoughts on lecture 13?
Uh, it's good. I don't know what to say. Uh, I think the anatomism. I've never heard of anatomism. Uh, but because I would have just considered anatomism to be sort of the same idea as atomism, just you know, where do we change the part?
It's just like think of it just like isolating function
Yeah,
and component, you know?
yeah, the function, yeah. Uh,
And that's it, remember, right? So okay, yeah. Remember, right? We're gonna bring it back to that, right? Uh, the loss of information, right? When you're reducing the function, the function of the whole, a behavior of the whole, right? A behavior only present at the whole. Remember, all this coordination, organization, and stuff. You're not gonna find it looking at the neurons. You know what I mean?
yeah,
But what they're saying is that we can reduce it to the neurons and not lose that information. That's what they're saying. In trying to isolate we can reduce it to this part in the brain, and we're not losing any information.
yeah, yeah.
But there's necessarily a loss of information.
Okay, okay, okay.
Because these parts they don't have like function like fixed in advance. They're not fixed in advance. Remember, they're living like they depend on the flow of energy through them. You know what I mean?
Right, like a weight is meaningless on a different planet, right?
Right.
If the weight of a clock is supposed to be used to be the well of energy, if you don't have gravity, it's not going to work.
Right.
Okay.
But it's really the point from thermodynamics, right? Like there's the loss of information because this is a dissipative structure. This is a, irreversibly like self-organizing, you know, like in thermodynamic terms, it's a dissipative structure, right?
Right.
It Yeah, you know what I mean, right? It's irreversible. Like it's an irreversible process, right? That's maintaining this structure here, right? That's like explaining the morphology, the parts, right? So it's not going to be fixed in advance. There's no fixing in advance of function here. It's impossible
I see. Right.
because then like it would have to contain literally the entire dynamics that realizes that function, which it doesn't.
Yeah, and
you
I
know,
mean, the function of something depends on the agent, right?
and the
Like,
environment.
yeah, like, you know, I could use I could use something for its the weight, right? Like,
Well, it's just
or
like look at the behavior, right?
right,
We understand the function here. We only understand it. We're looking at the whole. We're looking at the whole organism environment
right,
system,
right,
right? That's where we get this function from, right? This where we identify it, right?
right.
And then only then do we then isolate some part of the fucking brain or whatever,
Yeah,
right? And we tear that away, right? And then we say, "Oh wow, look, we can't do this thing anymore," right? The function must therefore have been in isolated in that part. But that's a loan that cannot be repaid. Remember, right? Because looking at that part, you can't identify the function, right?
right.
Where are you identifying it? Where are you getting it from? Where are you getting this function that you're
Okay,
attributing
okay.
to the thing?
I see
You know
what
what I
you're
mean?
saying. Yeah, I see what you're
You're
saying.
you're attributing the function to this component. Where are you
Yeah,
getting it from?
yeah, because you can't get it from the function. Okay.
You get what I'm saying?
Yeah, I see what you're
You
saying
can't get it
now.
from the properties and behaviors of the
Yeah,
component, right?
right.
You can't
Yeah,
devolve the properties and behavior of the organism onto the properties and behaviors of the brain, right?
right. I see what you're saying now. Okay.
You see what I'm saying, right? So you get
Yeah,
it. That's why
yeah,
that's why it's a loan of intelligence,
yeah. I see.
right?
Yeah. I'm seeing it now. Yeah. You can't just tear it away because you're already
Where'd you get it
assuming.
from?
Where'd you get it from?
Where,
You're already
where'd you get it from?
assuming that thinking was in the brain.
But where did you get it from? Where did
Yeah,
you get thinking from? This
yeah,
function that you're isolating,
yeah. You can't get it from the parts. You can only get it from the whole.
right? So this assumption that function is isolated in parts is completely like restrictive, like unduly restrictive assumption. That's just like it's unjustified. It's baseless. It's arbitrary. Yeah?
Yeah.
There's nothing that justifies it.
Nothing that's yeah. I see. I totally get it now. Okay. Okay.
Yeah. That's a way better way of putting it. I just realized.
Yeah. What you just said there made a lot of sense. Like you have
Yeah, restate it in your own words.
okay.
Yeah.
So the way I saw it was I think of it like a hypothetical. You have a organism in an environment, and through this organism environment system, you can get certain things. You can get thinking, breathing, blah 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 blah, all the things.
Mhm.
Nothing after you have the whole system, then you can break the parts into individual things.
Right.
And
Yeah, Bunge says this. Turvey references Bunge. He's like one of the first things he says in his book is like only once you have the system can you like break it open, right, for
right.
its parts.
Okay.
You know what I mean?
Yeah, so you break open the system, you can examine it, you can see the parts. But if somebody were to say, okay, let's take away a part, and because that's the part that thinking is done in, Where are you possibly getting that? Because the thinking is only in the whole. You can't get the part never entailed thinking
Where did you
alone.
get thinking from?
Yeah, where'd you get
How did
thinking from?
you're attributing thinking to this part, right? Did you
Right.
get it from the part?
No, you got it from the whole.
Right.
You're stealing it from the whole. You're
Right,
making it.
exactly.
Okay. Now, I guess my follow-up question is,
Stealing it from the whole. Yeah.
yeah, you're stealing it from the. My follow-up question is, you mentioned Turvey was talking about who? Bungie? You said Bungie?
Bunge. In the
Bungie.
first lecture, he cites Bunge on like the CES system, that stuff.
Yeah. Okay. Right. So I guess my argument is, or my question would be, what can you possibly like? What are you trying to
Oh yeah,
gain?
this is the quote. This is the quote. Only
Okay.
once you have the system may you proceed in taking it apart. That's what he said.
Right. Which that yeah. I guess my question like. I guess what can you even glean from taking it apart? Would it just be like didactic?
Well, obviously, if taking it apart destroys it, then you can't glean anything that depends on what you've destroyed.
Right. But what's an example of taking something apart that doesn't destroy it? Doesn't
Well,
take
we wouldn't be taking it apart.
right. We would oh okay, we would just be examining stuff
we
separately,
we would
but
we would be like I was saying, like I've said before, we have to try and find like the natural like metrics, right, that are like defining its own like behavior, right? It's like it's defining itself in like its own natural units that the system itself, establishes, right? And
right.
we find like the thermodynamic potentials themselves. They establish metrics, right? That we natural metrics, right? That we can use to relate, right? As potentials, like in thermodynamic terms, how potentials relate to forces and flows, and like how like things are ordered, right? Like
Right,
all in
right,
thermo, like all like that's all about thermodynamics, right?
right.
Like so we can just like uh
So
use it in that terms, right?
I see.
To you know what I mean? Like this is
So
all like this is what I was saying all in the first lecture, right? It was like living systems are like a natural classroom, right? For studying things.
I
Uh
see. Right.
without like destroying the thing you're trying to study, right? Like and like how biology can inform physics, right?
So once when we have this system, this whole system, we can then examine, okay, how does the structuring of light or whatever affect this optical array that we view, that we see, that we perceive?
Yeah, and
Like
Turvey really goes into that. Turvey, remember I linked like when I talked about this before, I linked to Turvey and Kugler's book where they talk about this like natural versus intrinsic measurement, right? Or I mean intrinsic versus extrinsic measurement, right? Like they natural and intrinsic are like the same, and extrinsic and artificial are the same, right?
okay.
Hello?
Yeah.
Hello?
I walked away. Sorry. Yep. Can you hear
And
me?
this is like
Yeah.
Rosen, like this is Rosen's first book in like 1979. Yeah, 1979, I think. He was like his theory of like measurement or whatever, and like how systems like define their own natural units, but like Turvey and Kugler like uh brought in thermodynamics and said like thermodynamic like potential, they define metrics, right? And that's just like perfect. Like they use that to discuss how information uh you know like guides like self-organization, like in building like how a termite nest is built, right?
Right.
They have a couple of papers on that, and that's some
Yeah.
really cool stuff.
I think you sent me. That's not the quantum scale one, is it?
Nah,
Ecological consideration. Okay.
it's the one self-organization, flow fields, and information.
Okay.
it's also in that book. Here. I'll link both of them.
Yeah, honestly, I probably already have it downloaded.
What you can do with the information, natural law, and self-assembly of rhythmic movement, that's the book,
hmm
is you can just like control F for like intrinsic or like extrinsic for what they say about that.
Okay.
And like also like some thermodynamic stuff in there is really good. But like it's also a pretty old book, right? Before Swenson. So it's a little bit outdated, but not so much, not too much.
Okay. Okay.
Like the thermodynamics is a little bit outdated, but it's not too bad.
All right. I see it.
And like they have the whole chapter in there with the termite nest too, but like this is also another paper where they talk about that. And there's also this paper too. This paper's Turvey's not in this paper. It's just Kugler and Shaw in this paper. Symmetry and symmetry breaking in thermodynamic engines. But yeah, they also have the termite example there. It's pretty cool stuff.
Okay.
But like this is like the basics of ecological physics. Like following Turvey, you know, like so it's not really, not everybody has adopted this. You know what I mean? Not
hmm
every ecological psychologist has been like really like serious about the ecological physics, right? As
Yeah.
Turvey has been, you know?
Yeah. They all got their little realms that they like to that they're
Right.
interested in.
And somebody needs to be the integrator, bro. You know? Somebody needs to come along and do the
Oh, did you drop?
end on my computer. My bad.
Yeah.
Hello?
Yeah. You cut out for a while, but
Yeah, I joined on my computer. That was
oh,
my mistake.
you're good.
Uh yeah, somebody needs to come and be the integrator, and that's kind of like what I'm trying to do. You know?
Yeah. Yeah. You're working on a book, right?
Yeah.
Um.
Uh so yeah, basically chapter 14, right? We can breeze through this.
Yeah.
Gestalt stuff. It's just this isn't really important.
Yeah, I didn't think so. You said I did. The only thing I think would be like I like the morphological reductionism like picture or
Yeah, yeah,
the example.
that's like the point, like between like scale invariant laws, right?
Yeah.
With like scale specific consequences. I think that makes it really, really like clear. But I don't like calling it reductionism, obviously.
Oh. Right.
It's just reductionism to a common set of physical, measurement strategies,
Right. Right.
and
Okay.
that's like the whole thing. That's the whole thing with homeokinetics. Like scale to scale physics, interscale, up down processes between scales. That's what homeokinetics is about, again, as opposed to like a flat land physics.
Okay, so that would be
You were
like scale to
you were there
scale.
were you
Sorry.
there when we talked about that?
I don't know. Was that last lecture? Because I wasn't there last lecture,
That
but
was like the first lecture, bro, or the second
oh,
lecture.
I was there, but keep in mind, I was brand new to ecopsych. Like that was
Yeah. Yeah, if you search up homeokinetics,
Yeah,
on like Google, you'll see
you're
like
talking about like the tornadoes,
no,
right? Tornadoes and fire and
no, no.
no, that's
Homeokin
auto. That's auto. Yeah,
homeokinetics.
homeokinetics.
This is the stuff where I say like you know there's a scale of atomisms, or there's a scale of a continua sandwiched between atomisms at the scale, like the scale above that, scale below that. You know what I mean?
Right, right.
You know when I talk about that?
Yeah, yeah.
That comes from homeokinetics.
Okay,
Like if you
okay.
see the wiki page for homeokinetics, it's like flatland physics versus homeokinetic physics. Ordinary physics is a flatland physics, a physics at some particular level. There's no multi-scales, there's no irreversibility, which you need, multiple scales for. Right, scale to scale transformations. That's what the second law is about. But
Right.
anyways, uh, like nuclear physics, atomic physics, biophysics, social physics, stellar physics, whatever. Like particle physics, quantum physics, right? Cosmology or whatever, right?
Yeah.
It's like flatland physics, right? Yeah, flatland. Remember the flatland?
Yeah, the Flatlander.
That's a really good analogy because reversibility, reverse equilibrium, right? Equilibrium reversibility is not attainable. I mean, it's not. It's a zero. I mean, it's like. I mean, that's the recursiveness and the Newtonian formalism and all that, right? It's reversibility is the physics of the flatland, the physics of the homogeneous, flat space time. You know what I mean? And you cannot get to irreversibility, multiple scale. You can't get to the next scale, right? You can't get irreversibility out of reversibility, right? And that's a really important point.
Yeah. Okay.
Like, and it's made like it's illustrated like perfectly with the flatland, the flatlanders. You know what I mean?
Yeah, yeah.
But yeah, tools such as, like the laws of thermodynamics specifically, right? The laws of thermodynamics provide key relationships for the binding of the levels, how they connect, and how the energy flows up and down, the up down processes between scales. And what it means is that there is no fundamental substrate, no fundamental units, right? Nothing is fundamental with respect to anything else, right? It treats all complex systems on equal footing, right? There's no privileged scale. You know what I mean? It's it's
Right.
about uh, it's about appropriateness, right? What's commensurate with the behavior you're trying to explain, and that's in the Turvey and Corello paper I linked like last time on like fictions or whatever. You remember that?
Yeah.
They talk about that in there. Like appropriateness of description. Are you following, bro?
I'm I, I just don't I like this homeokinetic stuff, but I don't really know what I can sort of like go from I don't
I
know.
mean, you could probably search in the chat when I've mentioned it and I've given references for it. If you want to learn more
Okay.
about that,
Yeah.
because always refer to it. Whenever I appeal to something from it. I'm like yeah, this is from homeokinetics, by the way. Yeah, and here's some papers on it. Right, I always
Yeah.
take every chance. So you can see me explain it better. And what is we trying to tell me? We says he understands. Okay.
I don't believe that.
Constraint is any condition that limits the motions, reduces the degrees of freedom of a dynamical system. Yeah. This is not. Like, this is important, but not too important. Uh, we address each charge in turn with a synopsis of thermodynamic systems and implications preparatory to elaboration of non-integrable constraints. Yeah, you won't really like understand, like I don't want to drag on and try to explain, all these different distinctions, which are really just the same things we've already talked about.
Yeah, I agree.
Like harmonic and holomonic, non-integrative and integrative. Like these are terms of art. You know what I mean? Like specific terms in these specific theories, and that's really why it's hard to integrate all of them. Or like just like on their face. You know what I mean? But like unless you like somebody needs to integrate them, be an integrator, like and integrate them explicitly.
Yeah.
Like this is connected to this. These are saying the same thing. Right, and you look in the footnotes, right? Reversibility is possible only in limit of infinite slowness, right? Reversibility is literally uh, infinitely slow, right? It's uh, the closer to perfect reversibility, the closer to zero is this, like it's literally a zero, like a zero, like it's an ideal limit, It's not, you cannot reach reversibility by any finite means in any finite time, right? It the point is, right? You can treat something as irreversible though. Right? You can treat something as reversible if you export all the irreversibility, if you use irreversibility, right? To export irreversibility, right?
Uh, what?
Remember the potential well.
Yeah. Okay, yeah.
Right. So you use it to export irreversibility, the irreversible dynamics, right? So you can just like treat it as reversible, like the sequences of symbols, is reversible, right? It's the recursiveness. Remember,
Right.
basically, there's no reversible processes in nature. It's not demonstrable. It's not evident. And for hundreds of years, physics uh, thought irreversibility was an illusion. Was an illusory. Product of the mind. This is the view of the second law as a product of the mind.
What?
Literally, for hundreds of years, they thought irreversibility was a product of the mind when it's like ubiquitous.
I'm not even sure how you would get to that conclusion, but I
Well, it's
guess
because the Newtonian worldview and everything. It's all reversible. It's
it's
all
all yeah.
it's all equilibrium, homogeneous.
Right. A particle pushes this way and then it pushes that way and it's reversible. Okay.
It's a zero sum game.
Right. Oh, right. Okay. Right.
I like to call it zero sum metaphysics.
Okay.
Instead of positive sum, a one, a unity. The first law. The first law says. But yeah. Uh, there's a lot of literature on this, right? How reversibility is not. There's no reversible processes in nature, right? It's an approximation. You know what I mean?
Mhm.
You can approximate reversibility, but only like you have to make use of irreversibility to do so, and that irreversibility that it's depending on, right, is not entailable by the reversibility. Remember?
Right. Yeah, that's interesting. Like the zero sum metaphysics. Okay.
Yeah, I have notes about that too. Um, do 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 do. Here. Uh, infinitely. Yeah, yeah, and it's like in a reversible world, like think about how you're trying to uh hold up. I don't think I'm looking at the right note here. I gotta search for it then, because I don't remember where it is. Infinitely slow. Yeah, there's some about it in organism environment system, and there's another note called measurement versus mapping, where I talk about it. Let me see here. Like it's in everything, you know, like the I'm trying to find the example here. Where the fuck is the example, man? Here, a frictionless air track is not frictionless. Right. When we're trying to, fuck's sake, bro. Why don't I have the example here? Like basically, we have to clamp, filter, cool, bias. You know, like saw, like smooth out. You know, like we have to like fit the ideal, right? We have to fit the thing to the ideal, right? To even like study these things, right? Like when we're talking about when we're trying to study acceleration, right? In Newtonian terms, right?
Right.
We need like a frictionless air track, right? That suppresses friction. You know what I mean?
Mm-hmm.
Because we
Yeah.
need to set this up. We need to set up this pocket of reversibility. You know, like this we have to set up these conditions where we can treat it as reversible. We can treat it as frictionless. You know what I mean?
Yeah.
By suppressing it, right? By suppressing the dynamics, by suppressing it. And that's how we study, you know, reversible processes. You know what I mean? This is literally straight state transitions, right? Basically all of physics is like even still like it's reduced to reversible like equilibrium,
Yeah.
you know, state transitions, perfectly homogeneous at every step. Like the process, you know, the process is identified, right, by uh you know, there's a test, right? You take every single, like if you can identify this, you know, property or whatever in every single micro state, right? The whatever is the structureless, you know, particle, right, that you're taking, now physicists like is just like, well, we just ignore the structure underneath it, right? So we have these structureless particles, right? And so we have to test at every single step, right? Is we're identifying the action, right, with something we test at every single step at each of these micro states, right? What does that do, right? Where's, like, if it has to be like yes, like at every single microstate, right? It's a Boolean measure still, right? We're identifying the action with this Boolean measure. We just test at every single microstate, right? If that's the case, where's the change? I mean, it's perfectly homogeneous. You know what I mean?
Right.
There's no change, right? Change is when there's no change. You know, motion is a set of immobilities.
Okay, yeah.
You see the contradiction there?
Yeah, definitely.
This is the static worldview, you know? And this is like, this is just everywhere in physics. It's ubiquitous in physics. It's just like, well, we're reducing it to, you know, like these, like, you know, what's it called? The model, or, you know, what's the
Yeah.
name for the model? The basic
Uh,
model or whatever.
yeah, we're Newtonian
Like the basic model of particle physics, you know, like
yeah,
it's not basic, like the term before model, I forget what it's called. You know, there's a term.
standard model.
Yeah, I think so.
Yeah, standard model of particle physics.
Right. That's the standard. Literally, those are the standards. They're telling you their standards right there. Right? For any action, for any process, literally any macroscopic process, you have to reduce it to these, you know, uh these these standards, right? At every micro stage, right?
Mm-hmm.
So what is that? That's not a physics of change, of motion. There's no motion, no change at all in the world described by uh the standard model. Literally none. That's crazy, right?
Yeah, I don't like it.
Yeah, I mean it's pretty crazy. I mean physics is literally supposed to be the science of motion.
All right, well, what are you thinking about now?
Um,
I mean, we've been going on for quite a bit, so I'm sort of.
are you like
I'm
what's it called? Are you, you know, like
a
tired
little.
out?
Yeah,
Out?
it's more like yeah. I think
You're
I'm a little
fried, you know?
I'm a little fried. And to be quite honest, you know, if we already said we're skipping 14, but I'm not the person to really talk about like 15. I
15 is important.
I know, but I'm not gonna be able to defend it. It's something like Eddie or somebody else would be
The
able to.
doctrine of intractable non-specificity. That's what I was talking about earlier.
Yeah, there it is.
Uh,
Yeah, 15.3. Yeah, like
Yeah,
Eddie
you'll
would
see.
probably
I
be.
have I have notes about this. You know, I use this to illustrate the doctrine of intractable non-specificity and the dualism, right? The behavioral and geographical environment, like it makes the dualism really clear. Like you'll see that you can search in my notes for where I talk about this, and I think I made it. I talk about it like very a lot like simpler, you know, like just like in essential terms of what I thought was important here,
Yeah,
because what he's doing here is he's in the context of a lot of the other papers he's written, you know, like he's like these themes show up a lot, right, where he's talking about the doctrine of intractable non-specificity, right, and the doctrine of uh the incommensurability of natural kinds, right, an incommensurability of natural kinds,
yeah. I feel like
those
this
two specifically.
this would be great for me to hear you and like Eddie talk about it because I could pick up from
And what
that.
what I've like basically intuited is like fucking the doctrine of intractable non-specificity is, well, like that's a violation. That's the violation of the first law. And the doctrine of the incommensurability of natural kinds, right, is really the violation of the second law.
Hmm. Yeah.
Yeah, the doctrine of necessary specificity. I like how I don't. He doesn't give the explanation of it here, but I like how Turvey and Shaw, like 1979. I like how they explain it. That's a really good paper. Let me give you another paper here.
Oh. Wait, when was this book written? Two...
2019. It came out.
Holy shit. Oh, okay.
Yeah.
Dang, this is a new
BC.
book. Okay.
Uh,
We did say something about the paper.
the primacy of perception. Yeah. Here, I have my notes on this. Uh, necessary specificity.
Yeah, you were talking about the other. Well, you were talking about the other paper, right? Yeah.
In my notes, I have a note. Necessary specificity, where I'm like taking quotes from this 1979 paper. Yeah, the ecological theory. Here, I really like this. I really like this. What they're saying here. Uh, the upshot of that. The upshot is that animal environment synergy, mutuality and reciprocity, advocates a doctrine of necessary specificity, and in doing so, it offers a further guideline for choosing a grain of description, namely, that there must be specificity in the coarse grain despite demonstrable non-specificity in the fine grain. That is to say, there is a grain of description at which the patterned energy is specific to the environment. The ecological theorist charges unequivocal. Pursue ever coarser grain sizes of description until the specificity is realized.
Yeah, he's not gonna
At a
find
deeper,
it.
yeah, at a deeper level, the challenge is the developmental theory and the development of theory and research directed at understanding how specificity is preserved over the components of an organism environment system and the perception action cycles that it manifests. Right, and Turvey has done that. And following this is in 1970, he did that with active, effortful touch and all that stuff. There's a lot of papers on that. By active touch, he's like, oh yeah, you're not. I don't know if you're looking at the paper, right? He gives a parenthetical, like in case of perceiving adjacent surfaces by active touch, for example, the aforementioned components would include properties of surface layout, patternings of mechanical energy, and the states of muscular. The states, yeah. I don't like, the language is not precise yet. Of muscular, connective, and neural tissues, right? He's like,
Yeah.
he's basically anticipating his later theory of active, effortful touch, and then also, the tensegrity hypothesis, right? The multifactorial tensegrity medium, for haptic perception, but which is like also just like for all perception and for understanding, synergies, right? Just like functional components, right? Like we're on the biological, on the organism side, like understanding the effectivities, right? Or like the brain as a functional component, right? Or the like the brain, eyes, head, system, right?
Yeah.
That's probably not the best description. We were talking about functional systems and stuff in the first lecture, right? And synergies. I don't know if we ever talked about synergies. Turvey has a bunch of papers on that too. It's like uh, it's hard to explain synergies for some reason for me. Like, or to just like motivate the idea at
Mhm.
first. Uh, it's like basically affordances, but the instead of the environment in organism referential terms, it's the organism in environment referential terms. You know,
What?
it's basically the ecological idea of, like how we understand, like the components of the body and stuff, the organs and like the arms, right, and all that stuff. They're called like synergies, right?
Uh, yeah, I'm not getting it. Are you saying like our understanding is what is a synergy?
No, I'm saying they are called synergies, like these things. The arm is a synergy,
The arm is
right?
a synergy.
Your hand is a synergy. Your fingers are synergies. That's the term.
So everything's a synergy.
Yeah, pretty much.
Okay, then nothing's synergy.
Like Kelso has like Kelso talks about that. Oh, if everything's a synergy, nothing's a synergy.
Yeah, I
It's
don't.
like that's why it's kind of hard to
Okay.
explain. Like like physiology, bro. Like it's
Mm-hmm.
like like it's the ecological psychologist like version of it. You know what I mean?
Okay, okay, okay. So it's a physiological thing.
Yeah, that's what it's about.
Okay.
Like basically they're also known as coordinative structures or dissipative. Coordinative structures are dissipative structures. Synergies are dissipative structures. It's the same thing. Remember what I was talking about dissipative structures before?
Yeah, yeah.
It's the same thing. Like literally, Turvey has a paper. Turvey and Kelso, they had two papers titled "Coordinative Structures as Dissipative Structures." All right, here's a new paper. Turvey's coordinative structures appraised. That was in the special issue in memoriam. And here's what I have here. This is important. This is why I did this. This is why I did this. I put all the links for synergies here. You oh yeah, you read fucking Introduction to Ecopsych, right?
Yes, I read intro.
Yes, bro. You remember that you don't remember synergies
I
in
don't.
Ecopsych?
I don't
In
even
Intro
think
to
the.
Ecopsych?
I don't think it used the word synergy.
It
Let,
definitely did.
okay, let me pull it
Here,
up.
here in VC text, I here's the link here. Right. I think I do. Yeah, chapter 12. I also referenced there, chapter 12, Introduction to Ecopsych. But you see the link there. I collect everything here about synergies right here, and where I just linked in VC text.
Oh, okay, yeah. The concept of synergies. Oh, okay, it was the hammer. Okay. Yeah.
Right. Yeah. Yeah. You remember the hammer, right?
Yeah.
I forget. They explain it really simply. I don't know. I just forget their explanation. Maybe that's why. Are you? Do you
Yeah.
have them pulled up?
Yeah,
Yeah.
yeah, yeah. I'm looking.
Yeah. So yeah, you know what a synergy is. They're basically the like. I don't want to say the atoms of behavior, but it's like the analogy.
Yeah.
Kills
Yeah, don't say that.
the units of behavior, right?
The units of behavior. Okay.
The organism,
Yeah.
like the
It's like
units of the organism,
yeah,
right?
because you achieve the same the given behavior, by
Right.
swinging the
They're
hammer.
functional synergies.
Yeah. Functional relationship among independent anatomical parts. The purpose of synergy is not to produce a movement but achieve a goal.
Right, and you see where I linked in
Yeah, the tennis racket.
VC text.
Yeah.
You see where I linked in VC text. Like there's a paper there too by Turvey.
The senses
One of these.
considered. Well, yeah, the tensegrity one. I
Here,
have
here,
both of
here. This
these.
one. You see the third link in the second message.
Third link in the second message. Okay.
Action and perception at the level of synergies.
Yeah, I have. Okay, grabbed it.
This is Turvey's paper explaining synergies. You see, he also, brings up impredicativity, all this stuff, right? Very, very good paper explaining synergies. And like, da, da, da. There's also where the fuck is this paper? Nature of motor control. Yeah, the fourth link, right? This is another paper by Turvey where he's talking about the perspectives on motor control and all that. And this was like in a book, there's like a paper. There's another essay in this book by Kelso about synergies. So he's talking about synergies there too.
G, you better start writing papers if you're gonna catch up to these guys.
I know, right?
Like, God, so many fucking papers.
But there's a large body of like work on this
I know.
about synergy.
No, and you're still young, so.
Did I link this Scholarpedia? You see the Scholarpedia link by Kelso. Kelso.
Where would that be?
It's in that VC text link in
Yeah.
Zulu search.
Yeah, I'm looking at that. I don't see Scholarpedia.
Some FAQ
Oh,
about
there it is.
synergy.
There it is. There it is. I see it.
Yeah.
Okay.
Like
I don't even know
synergies is
how did we even get onto synergies? I have no clue.
I'm not sure. Yeah, I'm not sure at all. Well, you have the
I
recording.
have no clue. I literally have no clue how we got.
You have the recording, so you can see.
I do, yeah. All right. Yeah, we'll have to get
Oh wait. Okay. I was reading my notes on necessary specificity, and then Turvey, you know, uh, brought in his example, like the example of his work on, active touch. And he was saying that the components, right, the synergies would include properties of surface layout, right, and patterning of the ambient energy patterns, right. So it's like the synergy, it's not just like my arm is pretty much just like another surface. You know what I mean? I mean, it's like it can obviously I can have a synergy with my arm and also like a thing that's not part of my body, like a fucking like a rod, and that's part of a synergy that I'm controlling. I'm controlling the functional description of it. I really like that way of saying it. You're controlling the functional description of the event, right? That's the way Turvey says it in that nature of motor control paper, right? And he also says it in this paper. Carol, there it is. Turvey, 2016. Why can't I fucking find it whenever I search in my files? Shit. There you go. I really like this way of describing it, like, because it's like the system is always active. It's really about like you're like squeezing out the dynamics. You focus on you attend to certain constraints, right? You select certain constraints, and that squeezes out the dynamics, right? Focuses it. You know what I mean?
Mm-hmm.
Right.
I
It's
mean,
you're tweaking the system is always active, right? So you're just tweaking the dynamics, right? And using the environment to do that, right? Like, as reference points, right, in the environment. Yeah.
yeah, I mean, like you always hit the same spot with the hammer, but your movements are actually micro level variations.
Right. Yeah. Here. They say Figure 2 makes evident the central fact that the actor agent controls the functional description of the event participated in rather than the body's functional description. It also makes evident that from the theorist's observational perspective, any inquiry into skilled action must be fully inclusive of the event. That's really like Fowler and Turvey's, work is really cool on that stuff. And this paper was like in memory of Fowler because she died. Yo.
Yeah, I'm here.
And
I just, I think,
this is a pretty short paper, pretty cool paper.
I think I'm all eco psyched out for today.
How many papers have you saved? You saved all these papers?
Yeah, I've been saving them. I've got a little list that I've put on my tablet. I mean, I've read some of them. Like, I mean, I'm not. It's just some of them. It's hard to go like, okay, this is what I'm interested in, and then, like I said, I really like the quantum-like issues. That one I'm really interested in, and the senses considered as one perceptual system.
Yeah, you want to talk about it?
I haven't read them yet.
Oh.
I've read um yeah, I've read like the world is full of a number of things, which is like that one was whatever.
You don't like that one? I like that.
Well, it wasn't. I thought it was interesting. Like I think the baby stuff is interesting, but it's kind of like it's it's just like I agree. Like the world is full of so much things. Like you know, um,
Yeah, it's just like the point that Gibson makes is like not Eleanor Gibson, but it's the point that information is inexhaustible. That's important, right? Like, because I mean, it's like he says it's like a test of reality, right? Because you can endlessly scrutinize, finer and finer details of something, right? More and more details of something, right? But that's not you. There's no image that you can do that with, right? You cannot do that to images, right? No form of an image you can scrutinize endless detail in it, right?
right.
And or if you were imagining like something, right, it only has so much content as you give to it, right? So like if you were imagining like a toothbrush, right? Like you try and count like the bristles or whatever, you know what I mean? It's not like you're scrutinizing an object, right? You're just however many bristles I decide there is.
Yeah, yeah.
There's nothing more to like discriminate there. And the reason, and another thing, the reason, right, why, uh, you know, something has an indefinite amount of properties, right? There's just like you can't say that it has this finite list of properties, right? Because there's so many things, right? And what its properties are it's you're including it in its own relationships, right? Its own relations to other things in order to talk about any given property, right?
Uh-huh.
So
Yeah, like,
yeah. So
you know,
you can just keep doing that. You just like anything you like take a fucking water bottle and just include
yeah.
it in its relations to literally anything around you than anything else, anything you find, any other detail, right? That's how you can just, talk about it forever, right?
Right, right.
You won't run out of things to say about the water bottle, right? Because there's all these other things in the world.
Right. And as you would talk about the different scales, right, you would move up and down, right?
Right? That's the loopiness.
See, that I think I get that. I'm just
Remember the impredicativity. That's I don't think I finished that point, right? It was like in they're defined in terms of one another, right? But uh it's like you it's both ways. Remember, like it's like uh remember you can only chop the pizza up once you chop it up in triangles, you can't chop it up in squares, right?
right, right.
You know what I mean? So you go one way in the predicate, going one way, one direction, right? And in the impredicative like entailment, right? X entails Y entails X, right? Going one direction is like cutting the pizza up in squares. Going the other is like cutting up in triangles. You know what I mean?
Mhm.
Like in the sense that you go one way, you're not going the other way. You know what I mean?
Right, right.
Um, but help me connect this back. What am I responding to? I
So
forgot just for a second.
yeah, so we were talking about the improductivity of like the water bottle, talking about
The loopiness,
the
right?
loopiness.
Right. It's because it goes both ways, right? It's like, okay, I'm at X now. Well, I can just, go on back to Y, this way. Well,
Right,
I'm not really going back to Y in reverse. You know what I mean? I'm going to Y from X. You get what I'm saying?
right, right. I think yeah.
Because it's all connected.
Mhm.
You know, it's a closed loop of entailment, right? But it's not homogeneous, right?
Right,
It's not linear.
right, right. Yeah,
So
yeah.
like you're gonna have once you like get to the X, you're gonna have these connections that take you to Y.
Right.
And then you go to Y, you're gonna have all these connections that take you to X a different way. You know what I mean?
Yeah,
Just like cutting it in a triangle this time.
yeah.
So that like yeah, you get what I'm saying?
I
Right. So
think
like
yeah, I think
connect that
so.
with including the thing in its own relationships, right? It's participating in its own definition. You know what I mean? It's participating in its own definition. That's impredicativity, right? And so there's the loopiness there, right? When you're talking about any other thing in that context, right? You're talking about the context where the other thing, like the water bottle, right, was also participating in its own definition, right?
Right.
You got what I mean? It connects back to it.
And I guess like if we want to, could you say like, well, okay, I get it. I think I get it.
I mean, just like I can include the water bottle in its relationship to, you know, fucking this book, right? I can put it on this book, right?
Okay.
It's
Right.
it's it's it's
But those,
bluer than this book, you
but
know,
those are the same scale.
right? But then I can also talk about this book, it's in relation to the water bottle, right?
Right, but that's still the same scale.
But it's different. I'm not talking about the water bottle anymore. I'm talking about the book. But I'm talking about the book in terms of the water bottle. And then, but when I was talking about the water bottle, I was talking about the water bottle in terms of the book. You know what I mean?
Mm-hmm.
Like, because I can do one, I can also do the other.
Yeah, I think I get it.
Try and put it in your own words.
So the way I see it is that if I'm examining the water bottle, right, I've got this. Let me do a Coke can because I have a can right in front of me, right? I have this Coke can, and I can examine it in relation to other objects based on any of its properties. So, and it has an infinite amount. I shouldn't say infinite.
Its properties are its inclusion relationships,
Its
right?
properties are its inclusion. Oh, okay.
Including it,
Right.
including it. You're including it in its own relationships with other things.
Right. Right. It's red versus my phone or
The
my watch.
background,
Yeah,
the
the
background.
background, right? It's metal versus the wood table that it's sitting on. It's and then I can examine what makes it metal. Well, it's what kind of metal is it? Well, it's aluminum, right? Versus
Think you want to think more in terms of actions. Like properties are really like this action is performable. You know, it's movable. I can it's
okay.
put on touchable of this book, right?
Okay, so it's light enough for me to pick up and put onto a
Right.
table because
The
it's made.
sound of it when I flick it, like when I hit this other thing against it,
Yeah, it reverbs or it doesn't because it's got liquid in it versus wood that is dull sounding because it's solid. Um, but I don't really see how examining it separately from the
I'm saying
making.
if you can say I'm saying in action terms, right? In terms of action,
I don't get that.
right?
I don't.
In terms of activities perform when you try and do a able, say able, uh, like every property, right? Should be it's able, it's blank able, That's what you should be saying, right? And then you'd be able to just go on forever.
Right, but like what? Okay, it is visible because it's reflecting light or whatever. I shouldn't say that. Right? It's visible. Right? It's structuring light. But like, what do I say about? Do I say that it's readable versus blueable?
Uh, no.
So like what?
It's perceivable as blue.
Well, because remember, we don't really we don't see colors as such. Just
Yeah,
as an
colors
abstract
as
property.
in relation to other colors. Right.
Well, yeah, we see colors as in terms of affordances and activity relevant terms. What we see is a ripe thing, or a fucking edible thing, like If it's like the color is really like connected to like its texture, right, and its chemical like composition. You know what I mean?
No, but I only see edible things because of
Just think
well,
about it like this. Think about more like there's a lot that has to do like think about it like texture, right?
okay,
Like texture, like this thing is like more rough. Like
yeah,
if think about if you were to rub your hand you know over
sand,
it, you know what I mean?
yeah, sandpaper versus brushed metal.
Right, right.
Okay, what? But like what? But both are touchable.
Right.
But they have different
What
actions
are
because
you perceiving? You
I'm
know?
perceiving roughness versus non versus smooth. I'm perceiving smoothness or roughness or sharpness or all sorts of
Or, or
things.
or it's really like you know, Turvey gives a bunch of examples here. Like lecture like fucking uh 20 something 25. He wants to talk about that. Here we go. There are three necessities for getting this lecture. Blah, blah. The first is the recognition of the commonplace nature of dynamic effort touch. Here's a sample of the multiplicity of words in the English language needed to capture its variant behavioral realizations in daily human activity. Supporting, shaking, lifting, hefting, wielding, pushing, pulling, probing, pressing, chewing, prodding, roping, bending, stretching, striking, tugging, folding, twisting, squeezing, turning, rolling, vibrating, right?
Uh-huh.
Like, obviously, this is just a problem with vocabulary.
Well, and
Like, it's like psychology is a very new science because we didn't develop the vocabulary to discuss these things until very recently, right? So we're uh it, it, it there's a difference, trying to describe it in like language, right? You know what I mean? Trying to enumerate these things in language when we it's like it's ostensive, right? Just like we perceive the affordance, even if we can't describe it like in like in exact like language, right? You know what I mean?
see, well, and I have this problem with affordances too. Like, I I agree we perceive affordances, but like I feel like
That's why we have to not be nominalist about it, right? The thing is, right? We're the affordance is not defined by whatever the fucking terms you use to describe it, right? The affordance is defined by all these other things, right? Like the organism environment stuff and like information, like the structuring. Like we're talking about how it structures light, right? And activity like organism referential, terms, right? At
mhm
that scale.
mhm mhm
At the scale commensurate with behavior,
right
right?
right
So we know where we're what the scale we're at, right? But like we know what affordances are. We know what like we know like I'm seeing right now. Everything I'm saying, everything I'm perceiving is affordances. You know what I mean? Yeah, I don't need to be able to like that's the point. I don't need to be able to like speak about it in language. You know what I mean? Like my cat can see affordances. He doesn't know how to speak, right?
well, it's just I kind of feel like if you say, like, would it be wrong to say I perceive entities? Like,
You perceive things, yeah.
I perceive things, but
But
affordances.
but when you're describing it, you want to try and use affordance language, right? You don't you don't want to try and like abstract away from the thing, right? You're looking at the thing. It's going to be in the action. You're going to see it, right?
Right.
I'm doing it. Like I can do it.
Yeah.
I do it.
It's
This is
it's
what I'm
only
doing. That's the affordance right
yeah.
there.
It's
You
only a
know,
chair. It's only a chair because it's sittable.
exactly. Like this is like, oh, where's the affordance? Right here. sit. You know, I just sat on it. Right?
Yeah,
I didn't
yeah,
sit on the fucking air, you know?
yeah. I'm not sitting on the electrons or whatever.
Yeah, I'm not sitting on the fucking electrons or the blackness of it, you know, or the fucking
Yeah,
the leather, you know?
yeah. Right.
Right? I'm not sitting on the components, right?
Yeah,
Its identity is not its parts or whatever, and you know what I mean?
yeah. I get you.
But
Oh,
that helps describe it, right? You just like just pick the thing up, start doing things with it, you know?
yeah,
You know what I mean?
yeah,
Those are the affordances, right? And you just
yeah,
like, oh, this is what I'm doing. Oh, I'm doing this. I can do
yeah,
this. I can do this. I can do that. I can like literally just pick something up. What can I do with this? I can do this. I can do
yeah.
this. I can do that. I can do that. And what
This
are
is
you doing it? You're relating it to the things around it. You know?
yeah. This is exploration, right?
Yeah, exactly.
Okay.
That's how you pick up, more information, right? Because we're talking about scrutinizing, and that's what I really mean, like exploration, you know? Because you can't just look at the thing in isolation, right? And then
Right.
relate it to things, right? You know what I mean? Look at the thing as a thing in like okay, like as a category. You know, before you start like relating it to other things, you just say the thing is this relation to other thing. The thing is this relation to this other thing. The thing is this relation to this other thing. You know what I mean?
Yeah. Okay.
So maybe I was like uh misleading when I said like this water bottle, right? You know what I mean? This
Mm,
pickupable thing, really. This
I,
pickupable thing,
this pickup, yeah.
this pickupable thing, raise upable thing, drink fromable thing,
Yeah, clear above bubble thing. I don't know how you
see throughable thing,
see
you know?
throughable, see throughable thing. It can
Like
be
no, and I'm literally telling you right now. I'm saying word for word exactly what I'm doing as I'm doing it right now.
yeah,
And that's what you should, like try it, pick up something and just call it what you're doing with it.
sure. Yeah, this Coke can, right? I can press into it. It's pressable. It is touchable. It's set downable. It's drinkable. It's openable. It's not closable, which sucks. Um,
And you can see how it's kind of like constrained by like the task, like what your goals are, you know? Like you don't want to fucking throw it across the room, so you're not really thinking like this throwable thing, I'm gonna throw it, you
yeah,
know?
yeah. I don't want to turn it upside down, right?
Right.
That'd be
But you
bad.
can.
But I could. Yeah, I learned a long time ago. Don't turn Coke cans upside down.
Because you see the affordance is there for you to learn,
Yeah.
you know?
So, is there something like negative affordances?
No, it's the same thing as disvalue, right? It's like it's a uh it's like you would have to sacrifice greater values for it, you know?
Okay. Right, that makes sense.
Like it's still a value, you know? Still has valuative content, right?
Yeah. And depending on
Like even
my
even the
values.
worst like the thing you would uh you wouldn't sacrifice anything for, you know?
Yeah.
What
But
you wouldn't wish on your worst enemy, that's a value too,
yeah.
right? It has to be, or else you couldn't evaluate it,
Yeah.
as a lesser value.
But depending on what I want, depending on my values, it would afford flipping over and dumping out all the liquid, right?
All right.
Like if I if
I
if it
mean,
if it went
it does afford it, but It's like that's the occasion variable.
Yeah.
You know,
Occasion
I don't know if
variable.
you were you there when I talked about that.
No, but I think it sounds pretty makes sense to me.
There's like a whole like formalism like like for affordances and effectivities, like just like if you search in Zulu server, occasion variable, where I say that because this is like from Turvey, he to explain how an affordance is like actualized, you search occasion in Zulu
Occasion.
server.
Occasion.
Yeah,
Occasion.
this is like the whole like the argument given by Turvey.
Uh, occasion what?
Occasion,
Variable. Occasion variable.
just
Yeah.
yeah,
Yeah.
occasion variable.
Yeah.
Not the first one you see, but the second one. The myriad facets. Yeah.
Yep. Okay, there it is.
Oh, there's a typo there. Compatible. I meant. This is in like lecture 22.
Yeah. He uses the word
But no, but
dispositional.
this it's not. It's not in this screenshot. It's
Oh.
in a section before that in lecture 22. But it's also in various other papers. You see. This is from my notes, by the way.
Mm-hmm.
But yeah, it's like this is what they use, right? Situation X affords an activity Y for an organism Z on occasion O, if and only if X and Z are mutually compatible on the dimensions of relevance to Y. And then, there's the occasion. I mean, the effectivity, which is the synergy you did. Like the same thing as the synergy. You know, an
Right.
organism Z can affect an activity Y in situation X on occasion O, if and only if Z and X are on mutually compatible dimensions of relevance to Y. And yeah, I gave a bunch of references there. I'm looking for the other screenshot I did because there was another screenshot, or was it above that? Where the fuck is the screen? Oh, it's right. It's right above that. Like right above it. You see?
Right above it. Myriad facts.
Like
Oh yeah, yeah,
just
yeah,
little.
yeah, yeah, yeah.
Yeah. This is from lecture 22. You see, he gives an example there with the hermit crab.
Yeah, the lacking the sea anemones. Okay. Well, we'll get to this in this book, right? 22. That'll be
Yeah,
coming
yeah.
coming up. Okay. Yeah, I have to say
But
I'm
yeah, the occasion variable is basically value scales.
yeah.
Rankings.
I have to say I'm feeling pretty burnout. Oh boy. I don't know how you do it, but
What was our last point? We were talking about something important
well,
before I got into the occasion variable.
we were talking about the can, right? And I said depending on
Yeah,
my values, it may be better for me to flip the can over and dump out all the liquid. And you said that's an occasion variable, which makes sense to me, right? Depending on the occasion, that
right.
will, you know, I wouldn't, I don't know if I would use the occasion variable, but I mean, that's, I think of it like depending on my values, right?
Right, yeah, it's the same thing. Yeah.
Yeah, same thing.
Uh, I just wanted to, relate that to what ecological psychologists,
Yeah,
say.
yeah. No, and I think that's good. That makes sense. You know,
But maybe it's like people don't really like. You see, it's like there's a disconnect, right? Like in their whole like intellectual like life, right? In their whole intellect, like their thoughts, right? It's completely like disconnected from affordances. You know what I mean? Because they're not thinking in terms of affordances.
right.
You know what I mean?
No, I agree. When
So I don't know what consequences that has. That might have crazy like consequences, you know?
yeah, I don't know. When I learned affordances from you, it made a lot of sense, and I'm like, yeah, okay, that makes a lot of sense. But to me, it's still like, okay, I still see and I still perceive entities. I just
Yeah, you don't want to. Maybe this is bro. Maybe this is where they're like where they're trying to where they privilege the third grade of sense. You know what I mean? It's like
uh
you get what I'm saying. It's like I'm trying to think about it. You know, it's like I'm trying to think in terms of affordances, right? And I'm trying to see that as like the basis, you know, instead of
yeah.
just like what I see, what you perceive. Those are affordances. That's what you should be basing your thinking off of. Thinking of how to like how you would understand affordances, right?
Yeah,
When
yeah,
you're thinking about them, you know what I mean?
yeah, I
You
see what you're
look at
saying.
what you perceive, you know, instead of whatever you would think is taking whatever you think is primary. You know what I mean?
Yeah, probably because they don't think it's possible to see sitableness, right?
But that's what you see, you
Yeah,
know.
right. But they
They
can't.
just they're thinking about it in terms of, you know, not in terms of affordances, right? Because they're
Yeah,
not thinking in terms of affordances. They're trying to uh like it's like they're trying to rationalize it, you know.
yeah.
Like I don't see sitableness,
No,
right?
who would see sitableness? That's retarded. Like
But it's like
that's not a
because
particle.
they're thinking
Yeah,
in their thinking, what am I seeing? You know,
yeah.
like they ask the question to their thoughts, right? What am I seeing? Instead of asking the question to their eyes, you know,
Yeah.
to their behavior.
To their
Ask the question
behavior.
to
To their behavior.
yeah,
That's a
exactly.
better way to put it. Yeah.
Ask the question to your
Yeah.
behavior,
Yeah.
whether it's a sittable thing or not,
Yeah.
right? You know?
Why are you calling this a chair? It's not because of its color. It's not because of its, you know, what it tastes like. You're calling it a chair because it's sittable.
Do you need to reference your thoughts? Like, do you need to reference your like? I mean, like in language, right? Let's
Yeah.
say thinking your thinking language. I mean, you
Okay.
know the inner voice or whatever. Do you need to reference that when you're perceiving something as sittable?
No.
You know,
No. It's
no. So why would you take that as the reference of whether something is sittable?
where'd you take? Yeah.
You get what I mean?
Yeah. Yeah.
Like what it means to see something as sittable. Why would you take that as the reference?
Right.
Instead of what you're seeing and your behavior, you know?
Yeah.
Like, because I mean, just to sit on it, you don't need to reference your thoughts. You know what I mean?
Yeah.
That's what I mean, right? You just need to
Yeah.
reference the perception. You just need to reference what you see. You
Yeah.
know?
You don't need to reference the size of your butt. It's, you know,
Yeah,
your butt. You already do that. You already know. You know, it's already a chair depending on the size of your butt or how big you are.
right. It's a seat. It's a sittable thing.
Yeah.
Sit onable thing.
Yeah.
Yeah, I think that's like a we just came at a really uh important point, right? And I mean, that's exactly why they would privilege the third grade of sense. I think,
Mhm.
right?
Yeah. That sounds. Yeah. But I can't answer your question as to like what, you know. Yeah. What does that lead to? Because I never saw things as affordances my whole life. So, but
Yeah,
it.
but and by what standard are you saying that? Right? Is the standard their perception, your behavior, or is the standard your rationalization? Right?
I don't. Yeah. That's weird. I never.
Right? It's a little bit weird, but it's like just like when you're saying uh like what is an affordance? Like when you try to think about it, right? What is an
Okay.
affordance? What should you be referencing? You know, what you just reference the behavior. You reference the thing, what you're
Yeah.
seeing.
What can I do with it?
Right. Like it's like that, and that's what it is. That's the affordance. You know what that's what seeing an affordance is. It's just seeing what you like normal, you know,
Yeah.
what you do see, right? That's really what you should take as the basis for understanding what affordances are, right? Before even thinking about what they are, right?
Right. Right. Right.
I don't know. Can you maybe state what I just said much clearer?
I probably can't do it clear, but the way I see it is that what you see, what you perceive as affordances, is not reference to your thinking or your thought or any other, whether it's rationalized or whatever. Perceiving is a primary, like perceiving affordances is primary to all perception. I don't not see what I perceive
I don't have
as
to infer affordances.
yeah,
No?
what I perceive as affordances are true. They're primary.
It's like I'm trying to infer affordances. You know, I'm trying to infer affordances from what I think, like my categorical, you know, like my classification of what the thing is, you know, in my
How,
thoughts. You know?
gee, I don't even know how. Like, how could you even do that? What
You
would you even?
can't.
Yeah, what would you even come up with?
No, you can't, right? And that's
It's,
why it's hard for them to, you know, grasp it,
yeah,
right?
it's complete nonsense. Like, I can't even imagine looking at something like trying to infer what a Coke can do. Like what the
Yeah, I mean,
affordance.
you don't have to think about it. You don't
Yeah,
have to you don't have to lay out like a proposition like in you know words like about what you can do with it. You just see and do.
yeah. And I mean, some of the things that I hear about, what like rationalists do, I just don't get it. I don't.
Yeah, I think we should take this last point and like with the recording, you know, and put it in like Chat GPT and tell it to, you know, refine this
So,
point
I,
like super precisely because I think this is a really good point.
yeah, I can do that. The Google AI seems to be all right, so I'll be doing that in that point, and then I think the point on scales was really good for me. Or
Okay, yeah. Let
yeah,
me know when you put
yeah,
that point together because I think is really good. Like it needs to be put precisely, you know?
yeah,
Because like you just grasped it completely right now, right?
yeah,
From me
yeah,
just
yeah,
making that
yeah.
joke.
I that and then the other point we made was yeah, but yeah, I'll edit it and I'll put it through and may
I really want to see that point just like
okay.
that I can make it very easily, bro. Because I've like been like circling around that kind of that point.
I'll tell you what, man. You should use AI to help you write, your books or whatever. Like it's
I do, yeah.
okay. Like I mean, it's it's awesome. Like even just putting your discussion with Casm, I say discussion, it really wasn't a discussion. Even putting that in, it's just like I just love how even the AI knew that he was abusing his power.
Yeah, I mean, you can see in my notes. I take a lot of notes with
Yeah,
Chat GPT to jot things down and like help me make some connections. You know,
yeah, yeah. The black holing one was, yeah. All right.
I'm just like really like proud of that point, bro, that we just got to.
Yeah, I'll put it in. I'll put
Like
it in.
why they're privileging the third grade of sense. Like
Yeah.
I've been trying to understand that, man. You know, I've been trying to get it.
I just
Like this
can't.
whole,
How I just don't. It makes no sense to me. Like what?
but that's like you've done it before. You know.
I don't. What? Have I? Have I?
I mean, like before you just grasped it now, the way you were thinking about affordances before, you know, like when you were trying to think, what is an affordance, you know? You get what I mean?
Yeah, yeah. You're saying I was inferring my affordances from my entities, from my
No, no,
knowledge
no.
of.
Obviously, you have a direct grasp of affordances, you know,
Yeah.
in perception and action, right?
Right. Right.
It's just that when you're not thinking in terms of affordances, right? Then it's hard to think about affordances. You know?
Right. I'm thinking in terms of entities or whatever, chair. Right.
Right? Yeah, when you're not taking what you're already perceiving as like what like the terms, right? The what affordances are, you know?
Right.
Fuck. The point was so much more so much
Yeah.
clearer.
Yeah. The I'll put it into AI and I'll get the or I'll,
It's a tricky point to get clear, but like I feel like once
Yeah.
it can be made really clear, you know?
I mean, it needs to be put on paper. That usually does the trick.
Right.
Yeah.
I mean,
Type down.
do you do you get the point? You
Yeah,
get the
I
point?
I get the point. I'm just not as uh, erudite as to really explain it. But once I listen to the recording and jot it down,
Okay.
it'll be good.
You're gonna do that like today?
Yeah, I'll do it today. I gotta take a little break. I've been
Okay,
yeah.
bet. Because like I'm really you know
You're
I'm kind of
wired. Yeah,
excited about that.
I can tell.
Yeah.
Yeah, I have to merge the audio together because it separates the tracks between us and then put it.
like it's like when I'm on like just like the tip of like a massive like integration, you know?
Yeah, yeah, I'll get it done. I just need to like
Nice.
I need to take a break.
Because that's what I usually do, you know. I take my like inklings that I'm getting, you know, because I'm getting these inklings of a fucking massive integration. Like
Yeah.
is like I'm almost there, you know,
I mean, if you
right?
want, I can just give
And
you the
I take it and I put it into like Chat GPT, you know, and like
yeah.
I try and like make it like really precise, right?
Yeah, I mean, if you want, I can just get it right now and like transcribe it as
Oh yeah,
Okay.
yeah,
Let
that'd
me.
be cool.
Okay, I'm gonna end the recording then right now.